Good morning all of you. My today's presentation is based on the ultrasonic study and allied physical meter, physical parameters of uni-univalent mixed electrolyte in formamide. This is a presentation which is prepared by me, Dr. Nidhi Sharma from PGMC College Pune and Ms. Swagat from the State College. Actually, in this work, I have studied about the different physical parameters which are related to the ion-ion and ion-solvent interaction. Before my study, number of scientists have discovered about the mixed electrolyte system, which is related to the propagation of sound velocity. Sound wave perturb the equilibrium between solute and solvent molecules, and relaxation process are set up leading to the excess absorption sound. Number of scientists has discovered about this thing. So, keeping in this aim in my mind, I have discovered a number of physical parameters by keeping the temperature 298.15 Kelvin temperature, and I have taken the three combinations. Like in one of the combinations I have changed the positive ion. Here I have taken the sodium ion, another I have taken the potassium ion, and the negative ion is same. Then after that again the same thing. Means I have taken the three type of combination in which I have just changed only the value of the positive ion. In one group I have taken the sodium ion, in another group I have taken the potassium ion. So by keeping these changes, I have discussed the number of physical parameters, for example, adiabatic compressibility, upright polar compressibility, intermolecular clearance, specific acoustic impedance, solvation number, and relative associated constant. And by keeping these all things in my mind, I have just discussed the different types of interactions, which is ion-ion and ion-solvent interaction. So to study all these parameters, I have just used the ultrasonic interferometer, discometer, and the simple electronic weighing machine to calculate the density and other parameters. So here I have just concluded the different results by studying this thing. First of all, I have taken out the density and ultrasonic velocity of different sets. So what I found, in some sets there is a system which is having the sodium bromide, sodium nitrate, potassium bromide, potassium nitrate, KBr, KCl, NaBr, NaCl. There the ultrasonic velocity increases, then the concentration of the first electrolyte increases. With the increase in the first electrolyte concentration, this ultrasonic velocity increases. Then in the system which is having the acetate ion, which is common in that, it decreases. It means there is a change in the ultrasonic velocity due to the change in that acetate ion. In other system, the size of an ion is very small, and in this system, the acetate ion size is bigger. So that's why it changes the velocity. So by increasing the concentration of this acetate ion, the velocity decreases. So it explains the structure making and breaking properties. Now again, when we come to the adiabatic compressibility, as it is the measurement of the intermolecular association and dissociation, it also determines the orientation of solvent molecule around the solvent, also all the solute molecules which are present. So there are different tables which I have given in my presentation, which shows that where is the increase, where is the decrease. So I brought out the count. Beta adiabatic compressibility. In these two systems only, this is containing potassium ion, KBr, KCl, KBr, KNP. Means in both the systems there is a presence of common potassium ion. In the rest of the system, in this system, the adiabatic compressibility decreases, and in the rest of the system, it increases. Means suddenly there is a change in the property just due to the potassium ion. In the rest of the system, it increases. So this decrease and increase again is due to the structure making and breaking property of the first electrolyte, which is KBr. In this system, the KBr is a common electrolyte which is decreasing the adiabatic compressibility. Now again the same parameter I have discussed for the intermolecular free length. In this ultrasonic I have studied the intermolecular free length, and finally I have concluded that again a parallel table shows that low concentration of KBr in the mixture KBr, KCl, KBr, KNP, the molecules are not closer. The beta adiabatic and LF, both get changes. It shows there is a strong interaction between the solute and solvent molecule. Such strong interaction may be due to the dipole-dipole, ion-dipole or hydrogen bonding system. Then again I have measured the acoustic impedance. In acoustic impedance, again the same sort of combination, the potassium bromide combination shows the different measurement. The increase in the system of acoustic impedance decreases with Y in this system. The increase in the value of acoustic impedance is supported by other scientists also, which they have discovered in the past. So, main thing, the structure making property of the first electrolyte in these mixed electrolyte systems, while the increase in Z supports the structure breaking property. So it means the structure making and breaking property is related to the Z. So finally, I have concluded that the increase in the value of specific acoustic impedance Z increases with KBr concentration, which explains the lyophilic interaction which is present between solute-solute and solute-solvent molecules, which increases the intermolecular distance, making relatively very wide gap between the solute and between the two solute molecules due to the presence of lyophilic nature of the KBr salt. Especially it is present in the KBr salt. Again, the next property is relative association constant. Again, the Parasolov table shows this relative association constant specifically changes the different behavior in case of acetate salt. Here the sodium acetate, sodium nitrate and the potassium acetate and potassium nitrate, the relative constant decreases and in rest it is increases. So in this case it has increased. It is seen that the relative association constant increases with 1. So it increases in the solvation of first electrolyte. As the relative association increases, the solvation of the first electrolyte is changed. Then in next, apparent polar compressibility. This apparent polar compressibility again shows the same type of the relationship. Like in KBr case here, the values are found to be little bit positive starting from the beginning. Then after some concentration of potassium bromide, the rest of the values becomes negative. And the last is solvation number. Solvation number has been calculated. Again, the same combination of potassium bromide, potassium chloride, and potassium bromide, potassium nitrate. The value of acid increases, which increases the decrease in ion-ion interaction. Because here the ion-solvent interaction, due to the lyophilic nature of potassium bromide, the ion-solvent interaction is more. So that's why ion-ion interaction decreases. So hence, shows that if there is the presence of potassium bromide salt, it is having more affinity towards the formamide, because the solvent which I have taken in this combination is formamide, which is a non-aqueous solvent, and formamide is having the strong hydrogen bonding also. So the combined effect of hydrogen bonding and ion solvent interaction shows that there is a more increase in ion solvent interaction in case of potassium bromide salt. So finally, it is concluded that out of all electrolytic combination, this first combination potassium bromide, potassium nitrate and potassium bromide, potassium chloride is showing a different behavior. Hence, potassium bromide is playing a key role in all the combinations, changing the physical properties like acoustic impedance, apparent polar compressibility, solvation number, increases with adiabatic compressibility, intermolecular clearance, and relative association constant decreases. These are the two parameters which are increasing, and the rest of the parameters are decreases with the potassium bromide. Irrespective of the total concentration of the solution, what the second electrolyte we have taken, just due to the change in the concentration of potassium bromide salt, automatically there is a change in the physical parameters. So at any given concentration, the different acoustic parameters increases and decreases. It shows the structure promoting or breaking property of the potassium or sodium salt, which is balanced and subdued by the different anions which are present in the combination. So finally, it is just concluded. These are the Parasolov work, the table which is showing the different behavior of all the electrolytes and in their parameters. So finally, it has been concluded that the